Hello everyone, my name is Nitin Chaturvedi and basically I am a chemistry faculty and we are going to discuss a topic in a different way as we regularly discuss about it. So there are different kind of patterns which we follow while we study any topic. Most of them are like turning the pages of the books and then try to learn them again and again and again. So what I am going to do, I am going to try this topic with a little bit different touch and I hope you are going to like it. So first of all, we will treat this as a character. You know, you have heard of stories, like a stories there are different characters, 1, 2, 3, 4 different characters introduces into story one by one, and after that we know how the story goes and what is the climax is going to be. So we are going to treat this study thing like that. So basically in the chemical reaction and equation there are going to be 4 characters, right? First character is going to be characteristics of equation. You know, when we are talking about the story, then we introduce our characters. Then we tell about the audience that what is the story is going to be. So first of all, this is going to be first point, which is characteristics of a reaction. Characteristics of a equation. Okay, the second main character, which is going to be balancing of equation, right? Third and the most important character, you know, every story has a great character or like which is played by a character artist because it's the main most important role. So this is his types of reaction, and the last character is going to be rancidity. So story has started, we have introduced 4 characters and now we are going to take this story little forward, you know. So first of all, if we are talking about characteristics, so characteristics of any reaction we are going to tell. Before that, we want to know that what is reaction. You know, what is the title of this story meaning? Hold the means. Okay. So whenever a reactant react, because of that we found a final thing that is called product. Right? In a chemical reaction, some elements, molecule or compound react and then we get product. In that process, what we see, breaking of old bonds, creating of new bonds, breaking of old compound, new compound will be formed. So these are the things which are going to see, which we are going to see. Now we will go at characteristics of a equation. So now we will proceed. In the characteristics of equation, there are 5 characteristics. First of all is so before proceeding further, we have named them characters. So what are these going to be? These are going to be sub-characters, side characters which are essential for the story moving forward, right? So first of all, change in state. How we can observe that? As in previous class you have studied about different kind of states like solid, liquid, gas. So in any reaction, if the state is changing, then it will consider or fall in the criteria of change in state.
4. 4 example, H2O solid, 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2
What is H2O solid? That means ice. If we give some heat, to this, it will convert into liquid form. So what are we observing out there? That there is a change in state. State is being changed. So in whatever equation, if there is any change of state, all those equations will fall into this criteria, which is called change in state. Right? Moving forward, another sub-character. Change in temperature or change in energy. So if there is a chemical reaction is going on, there is a 100% chances there is going to be certainty of energy change. This is also holds two more new characters. What are they? Exothermic and endothermic. So exothermic and endothermic. What is exothermic? What is this character about? So exothermic is about in which we see the release of energy. Like energy is being released, is gone out. And endothermic, which requires to absorb the energy. You know, if there is we have to put energy in something, or we have to supply some energy, then it will fall into endothermic. If there is an energy release, then it will be exothermic. So we will proceed further. Characteristics of a chemical reaction. We have seen two side characters. Now the third one will come change in color. So in some reaction we will observe, or we kind of see that there is a change in color, right? So change in color in whatever reaction we are seeing, that will fall into this criteria. The perfect example is this for rusting. Like as we know, iron can be seen in the color of grey, but after it got rusted, its color changes into reddish brown. So change in color, whatever element or compound is going through a particular change or is showing a change of color, it fall into this one. Now we will see formation of precipitate, right? So formation of precipitate. What is this precipitate means? So precipitate is kind of a thing which we get when we get, right? When two solutions react together, one of exchange of elements, because of exchange of elements, new compound is formed in the form of solid, and other is in the form of liquid, right? So that is called, which is formed solid, is called precipitate, and that kind of reaction will be called precipitation reaction, right? And the last characteristics, evolution of gas. Evolution of gas means gas is being releasing or coming out of that reaction. For example, if zinc complex H2SO4 reacting with H2SO4, so zinc sulfate will be formed and H2 will be evolving out there. As the gas is leaving, we will show it by upwards arrow, right? If we are showing that upwards arrow, that means the gas is being released. One more point, with the precipitate, if the whatever compound is forming as a precipitate, we will show it as downwards arrow, right? Getting my point? Hope you are enjoying the story. There are new characters will be there, so just wait. So we have discussed about the first character. Now we will move into second. So balancing of equation, right? So in the balancing of equation, there are two methods to balance any equation. First one is hit and trial. Like we attempt with different coefficients, because of that equation can be balanced. Like H2 and O2 are reacting and forming H2O. So we know there is O2, so oxygen will be twice. So we will put 2 here, and hydrogen is 4. That is why we will put 2 here. And because of this, as we see that on the both of sides, we are getting the exact amount of hydrogen and oxygen. The value is equal. That is why it is called balanced chemical equation, right? Sorry. There is another way. In the board exams, if they are asking in the category of 3 number question or 4 number question, then we have to present it differently. We will follow by, we will put some word equation first from the data given in question. Then skeleton equation. Then after that, table will be there in which we will balance them, and LHS and RHS. Like this, all will be called LHS, and this will be called RHS. And we will do different comparisons. Because of that comparisons, we will found the value and then put it at the right place. So equation will be balanced. So this was the second character of the story. Now, as I told you, third character of the story, the main one, right? And this character has a side character also, which is little bit complicated for some of you. Some of you might find it easy. So, types of reaction, there are 5 basically. And in normal days we divide or differentiate them on different bases also. Like reversible, irreversible. Reversible reactions are those which can be reversed in the reactant side, right? And irreversible is that which cannot be put into reverse direction ever, right? So first is going to be combination, decomposition, displacement, double displacement, and fifth one is troublemaker. So I will mention it here. That is called redox. In the combination that 2 elements or 1 element or 1 compound is reacting and finally producing a product, it will call as combination. Simple example, we will take like for hydrogen and oxygen combining and producing water. In the decomposition, what we observe in the decomposition reaction, it is just opposite of the combination reaction, and it is done by 3 methods, which are heat, sunlight, and electricity, right? So these are the 3 methods because of which we can, by the help of which we can produce a decomposition reaction, like electrolysis of water and different things, and displacement and double displacement. These sub characters are like brothers but different form. Okay, so these 2 reactions depend on a series. Reactivity series. What is reactivity series? In this series, elements are arranged in an order, like who is more reactive, that is put right up there, and who are less reactive are put down under, right? So there is a rule in the reactivity series that high reactive element can replace a low reactive element. Okay, we see that in nowadays in it is quite common, like more competent guy replaces less competent guy easily if there is a fair chance, right? There is some like support or approach, reference, it can be reversed, but in this only a high reactive element can replace low reactive element, and only difference by which we can differentiate displacement and double displacement is that displacement reaction is happening between an element and a compound, whether double displacement is always happening between two compounds, right? Because there is a certain amount of element to get replaced. Now the last side actor, redox. I told you, for some of you this might be a little bit troublemaker, but we will understand it by one equation only, and we can easily understand how to find out or what are the question can be made from this. I have to rub it completely to make this topic cover. So, redox reaction. So, what is redox? Redox is a mixture of two words. Reduction and oxidation. So we will understand all this, what is reduction and oxidation, by writing an equation. We are taking just an example. So this is an example of redox reaction, right? So in the redox reaction, what we see, there are some definitions out there. So you will consider them, right? Every time we do that. In the oxidation, there should be addition of oxygen, removal of hydrogen, addition of electronegative element, removal of electropositive element, and that is related also to oxidation number, right? So if the oxidation number ON is rising after the reaction, that means oxidation is going on. What is reduction? Reduction is just opposite to oxidation, like addition of hydrogen, removal of oxygen, electronegative will be removed, right? And oxidation number will be down, right? So in this is oxygen getting added on into zinc. So what is this? This is called oxidation. And oxygen is being removed, it is called reduction. So another point, here oxidation number of zinc is 0. Here oxidation number of zinc is 2. So oxidation number is increasing, that means this is a oxidation. There are two more terms which are associated or process with it are called reducing agent and oxidizing agent. I have a simple one line theory about it, that whatever is going through oxidation, whichever element is going through oxidation, that will act as reducing agent, and whatever element is going through reduction, it will act as oxidizing agent, right? So basically, and one last character, rancidity. Rancidity is basically nothing that different kind of food products, because of they have fats and other things, they get fungus and they get affected, they get like damaged in a different way, they smell very bad, and to prevent that, what we can do like packaging should be strong. Like for example, we put chips in a packet which also contain nitrogen, right? So we use different kinds of method to remove rancidity. So this is your topic, and I have tried to cover it in a manner that it should be look like a story, and I hope you enjoyed that story. And whoever is watching, thank you for your time, and have a great day. Thank you. Bye.